All right, I'm going to move on. Go to our next slide. And we are starting on lesson 3.3. So this week is our last week of lessons. Next week, we're going to take our unit assessment. So that's going to be our final for this class whenever we have that designated time for our final for this class. Okay, so we're going to finish lesson 3.3 today. We're going to do lesson 3.4 on Wednesday. We'll review on Friday. And then you guys will have your end of unit assessment next week. Okay, so today we're going to look at lesson 3.3, effect of collisions. So today we're going to analyze some data to explain how equal and opposite forces in a collision affect velocity change. And by the end, you guys are going to describe why objects in a collision change velocity differently when they experience the same strength force. So for our first activity, the warm-up, we're actually going to go into the simulation. And what we're going to do is we're going to select that 3.3 warm-up in the top left. Okay, there's going to be 3 little lines that you're going to press on, and you'll scroll down just like we did when we selected the different missions in the simulation. We're going to select the 3.3 warm-up, and it's the very last thing to select in our simulation. And so what you guys are going to do, you're going to run 3 sims. You're going to change the object B starting velocity as described in the data table that you will see. And then there is a very small data table in Amplify that you're going to fill out. So on this next screen, you're going to be able to click on the screen. You're going to make a prediction, and then you're going to run through the sim for the warm-up. So I'm going to press on the screen, and I'm going to take us through the instructions real quick and then let you go. All right, so once I'm in the warm-up, make your prediction, select from one of those 3, go through these 5 bullet points right here. So these 5 instructions. So you're going to open up the sim, you're going to select the 3.3 warm-up, and then record the mass of each object. And so this is where you'll record the mass of each object. You're going to run the test collisions. It says right here, you've got 3 test collisions. I'm going to let you guys do this on your own because last time we did one of the sims, I guided you all through a lot of it, and I want to see what you guys know since we are almost done with this unit. Okay, you should be able to run through the sim hopefully pretty easily. All right, once you set up each of these collisions, you're going to run it. You're going to look at the change in velocity on that Analyze page. So once you're in the Analyze page of the simulation, you're going to look at the change in velocity all the way to the right. Okay, so all you're finding is that change in velocity once you run each of these collisions. Okay, after that, we have got some reflection questions to kind of think about. What do you notice about the change in velocity in the objects? Why do you think the objects in each collision experience a different change in velocity? All right, so the only thing you're changing in here when you run the different collisions is the initial velocity of object B. Okay, that is all you're changing when you go into this simulation. So go ahead, click on that simulation, and go down to 3.3 warm-up. You gotta go to it in the top left corner. Okay, so you've got 3 simulations or 3 missions to run, and I'm going to give you guys, let's say 6 minutes. Okay, 6 minutes, so we'll come back at 10:21. All right. All right, so let's review this key concept real quick. We were given this key concept last Wednesday, I guess it was. And so this key concept says when 2 objects collide, a force is exerted on each object. The 2 forces are exerted in opposite directions, but they are the same strength. So the warm-up that you guys just set up, that warm-up was almost exactly like the simulation that we ran the other day. Okay? So we've already put this key concept down. I just want you to be very familiar with this one because this one is very important when it comes to talking about collisions. Okay, so when two objects collide, a force is exerted on each object. The two forces are exerted in opposite directions, but they are the same strength. All right, I'm going to put the Pear Deck link in the chat one more time for those of you that have not gotten on. All right, so let's share some of our ideas about the reflection questions. So these are the two questions that were at the bottom of your screen in Amplify. And so let's respond on Pear Deck. One question asks, what did you notice about the change in velocity on the objects? And the other one asks, why do you think the objects in each collision experienced a different change in velocity? All right, go ahead and answer those two questions in our Pear Deck. All right, looks like I got two people responding. All right, make sure you're typing your response in the Pear Deck. So what did you notice about the change in velocity on the objects? And then the second one was, why do you think the objects in each collision experienced a different change in velocity? All right, so somebody noticed that they both change velocity. You're saying the objects have a different mass, so different effects on the objects. They were each going at a different speed and had a different mass. Instead of saying speed, let's say velocity when we're talking about the objects moving. The more force the first object had, the greater change in velocity in the second object. Object B has a greater change in velocity because it has less mass than object A. The bigger object slowed down when it hit the small one, but the small one sped up. Perfect. So you guys are saying a lot about the mass of the object and the change in velocity of that object being greater than the change in velocity than the more massive object. So perfect. We're on the right track. All right, hold on just a second, guys. Hi. Did you get it already? No. All right, perfect. Awesome. Did you, I guess, turn it off? Is that why the, okay. All right, thank you. Sorry, guys, somebody was at the door. All right, so we have a reading. So this is not a new reading. We are going to read part of the article that we read the other day. And that article was the article titled Crash. And so what we're going to do is we are going to read, I think, the fourth and the fifth paragraph, or the third and the fourth. When we get to it, I'll remember which one it is. And then we're going to answer some new questions and amplify. So there's only 2 questions that we're going to answer, and we are only going to read 2 of the paragraphs from that article. All right, so before we do that, let's remember our investigation question. And so our investigation question is, in a collision, how do forces affect the objects? In a collision, how do forces affect the objects? And so I told you guys, today we're going to read this article with a new purpose. And so we're going to better understand the effects of force in collisions. All right, so let's take a look at some of the annotations you made. So in a second, you guys are going to be able to click on the screen and it will take you to the second activity in this lesson. And so we're going to reread part of the article and think about how to explain the 2 examples in the prompt. All right, so there's going to be 2 examples in the part that we read. And so you guys may want to highlight or annotate parts of the text that could prove helpful. All right, so you can go ahead and click on this screen, or if you're still on Amplify, you can just go to tab 2. And so what you're going to see here are your instructions. I want you to read paragraphs 3 and 4 of Crash, and then answer the questions on the right. As you read, you may want to highlight or annotate parts of the text that could prove helpful. All right, so paragraphs 3 and 4 are what we're going to be reading. All right, so go ahead, go to tab 2. If you want to check out those 2 questions before you start reading, that might be a good idea. So you're going to scroll down to paragraphs 3 and 4. And so paragraphs 3 and 4 are going to be those last 2 paragraphs. These paragraphs are pretty long. That's okay. You're going to scroll down to where it says bump. And then after that picture, you're going to start with, if you've ever driven a bumper car. All right. I'm going to give us a little bit of time to go back, reread this, maybe make some annotations if you need to, and then you guys are going to answer those questions. So those 2 questions say, what are the effects of the collision forces when objects with different masses collide? And then it asks, what are the effects of the collision forces when objects of the same mass collide? All right, let's take about 7 to 8 minutes, read this, annotate this if you need to, and then answer those 2 questions. If you guys need more time, let me know. I will check back. We will check back at 10:38 or 10:39. Okay? Make sure you're reading the article. All right, we have got a question here in Pear Deck after that reading. And so in that reading, it says something about 2 bugs, right? And colliding with a car. And so my question to you guys was, why was the end result of a collision between 2 bugs so different from a collision between 1 bug and a windshield? All right, so why was the end result so different for each of those? All right, make sure you're responding in Pear Deck. We should be wrapping up that reading and those 2 questions that were in Amplify. All right, looks like I have a little bit over half of you guys responding. Make sure that you're responding in Pear Deck. I'll go through those in just a second. All right, if you haven't written anything, make sure you do. There's about 6 of you that have not written anything in Pear Deck. All right, so the two bugs are the same mass and both going at the same speed, and with the windshield, it's more massive and has a faster speed. Perfect. Or a faster velocity. Good. Okay, so because the bugs have equal mass, on the other hand, the car and the bug had different masses, which it has different results. The two bugs are the same size and have the same mass. The car is big, insanely fast object with lots of mass. Perfect. You guys are saying almost the exact same thing. All right, so this had a lot to do with mass and velocity, right? And so the other things, although it may not seem like one is going faster or has a bigger velocity than the other, or maybe they're both the same mass, like the two bugs are, we have to know that mass and velocity are the two main components here when we're talking about collisions. All right, so we're going to respond to this Pear Deck question instead of being on Amplify. So you guys don't even have to get on Amplify for our third activity. We are going to do the word relationship routine. And so right now, what I want you to do is to answer this question using at least 2 of these cards. Okay, so our cards are velocity, force, collision, and mass. If you can use all 4, that's great. If you cannot and you just use 2, then that's perfect. You can come up with as many sentences as you would like. All right, I want at least one answering this question. Why are the effects of collisions different if the force on each object is the same strength? Right? Why are the effects of collisions different if the force on each object is the same strength? So when I'm talking about the same strength, if we think back to our simulations and we look at that pink arrow when we're in our analyze button and they're going opposite directions, that's what it's talking about when it's saying the force is the same when those objects collide. But right now we're talking about the effects. So why are those effects different? So use those 4 or use at least 2 of those words to come up with some sentences. I'll give you guys a few minutes to do this.